All right, what's the rule here? If the chords are the same, the arcs are the same. If the arcs are the same, the chords are the same. So since both of these are 7 in here, both of the arcs on the outside are going to be 121. Since both of the arcs on these next ones are 125, then those two chords would have to be 12. What do we do on one like number 3 down here? What's the answer?
80 for the
This part is 80.
yeah.
What's this one up here?
Just subtract them off 260. Yeah.
Add them all up and subtract from 360. It is not 140 because then it wouldn't add up to be 360. What do we do on something like this one?
They're equal, so set them.
4x equals 80 minus x. Solve. Then if I wanted to say what is CD, BC, DE, and so on. How would I do those? Take that 16 and plug it in. So 4 times 16 is 64. So that would give me the BC part. And then BE would be 80 minus 16. How would I find something like ED right there? I know that there's my semicircle 180, so 180 minus the 64. EDC, how would I do that one?
64 minus 360.
Well, I know this is 64, I know that's 64. I could do, add those two up and subtract from 360 would work. Or I could figure out this is 116 and that's 116 and add those two. Both ways work. What's the difference between inscribed and central?
Central is come from the center of the circle.
Central goes to the center and comes back out. Inscribed goes to the circle and comes back out. What do we know about the angles here? That's going to be the same. This one is, angle is half of the arc. The arc is always the big one. So BC would be, multiply by 2 on that one. Angle X would be, why is it 95? Divide by 2. Now on this one, be careful and make sure you answer what it's asking for. What is ABC?
We got something that says 200.
This part is 200, but it's not what it's asking me for.
360.
So I would do 360 minus 200 and get 160 for that answer. For some reason we had trouble with this. How much is QS? What do I do?
70.
Multiply by 2. So then that means RQ is how much?
RQ is the same as DS.
No.
It ain't really.
If RT, that arc is 60, then how much is angle S?
30.
So how much is arc TS then down here?
I was at 120.
Because
Add all of
there's a
those.
semicircle right there. So 180 minus the 60. This part here should be easy. Which two ones match over there? A and D are going to be the same. This one matches that one, and then these two match each other. If you see a diameter like that, what does that mean for this angle right here? It's got to be a 90, which means this has got to be 180, and then the top's got to be 180. If it gives you the one like it says A is 62 and wants me to find BC out here, multiply by 2. What about then angle C? How would I find that?
Well, that's 90, that's 62, so it'd be like 180 minus.
Add those up and then subtract from 180 would tell you that. Or I could do 180 minus 124 and get 56 and then divide by 2. Both ways work. What is the rule on this? If they're across from each other, they have to add up to be 180. So I would do that, and then I would do this. I said it the first time we went over it. I said it when we reviewed. And I'm saying it again. Do not set them equal to each other. Add them up equal to 180. Then you can solve everything. We okay with something like this? What do we do first? Do the outside part first. What is this one?
What, 180 divided by 123?
Well, 180 minus 123 is 57. This one is 180 minus 62 or 118. Then you've got to check. If it's the arc, like CD right here, you're going around the circle. How much is CD? 118. Angle BAC. What you're checking is the middle letter, the center. If it is, what does that mean? It's a central angle, so it's going to be the same. So BAC, B to A to C, is 123. The BAE, again, A is in the center of the number of letters and the center of the circle, so it's going to match. That would be 57. Number 4 goes back to an arc right there, so that's going around. CDB, add those parts up. Arc CED, you're going around again. Angle DAE, again, A is in the middle, so that means it's central. It's got to match the outside. All right, look here. BEC. A is in the center of the circle, and E is in the center of the letters. Therefore, that's telling me what? It's inscribed, which means this angle is going to be half of whatever arc. Well, BEC is right here. So it makes the 123, which means you divide by 2 and get 61.5. Same rule, CED. Here's CED, coming down and going back that way. Half of 118. Arc EBC, we're going around. That's 180. And then the angle DAC, A is in the center, so it's the central, and it matches. What's the rule on these? Angles half the arc. Same deal. So angle 1 would be 66. Here I would multiply and say that part's 220, and then that means that part's 140. What if it wanted me to find that angle right there? You could either half the 140 that you find, or say this is a line, so 180 minus that 110. Both ways give you the same number. What's the rule here?
Vertical angles.
Use the vertical angles. The angle is half of the one that it makes plus the vertical. Half of the one that it makes plus the vertical. If we're looking for the angle, that's what we're going to do. Half of the one that it makes plus the vertical. Now what would I need to do on the second one?
570. And wait.
First thing I need to do is figure out what that missing piece is.
So all them.
And then I would do that rule over there.
360.
So do the 360, add these up, subtract from 360, find this missing piece, then you would do that rule. What if it gives you the angle on the inside? Do we remember that?
Did you see how far it is?
First of all, figure out what angle we're dealing with. 52 is not the right angle. I need this angle, which is 128. Do we know where the 128 is coming from?
Yeah, it's on the center.
It's the center of the circle.
Yeah.
I mean, excuse me, it's making a line inside there, not the center of the circle. Makes a line, which means it has to be the 180. So then, if we've got the angle, we can do the shortcut. What's the shortcut? How much higher or lower is the one that you have? 128 and 144 is 16 higher, so that's got to be 16 lower. Half of the big arc minus the little arc. The only one you're going to do that on is when the angle's outside. What do I need to do on the second one right here? What should be first?
We gotta find one.
Find that one right there first.
So add all them up.
So make sure you add up the pieces, all three. subtract from 360, and then do half of whatever that big one is, minus the 30. Very simple here. 6 times x equals 5 times 12. Set it up and solve it. What's the rule on these? Good. Outside times the whole thing equals outside times the whole thing. We weren't going to get it, so we don't even know.
I might have.
All right, we'll do the second one then.
Okay, 5x equals 6, and there's one more. 5, 6, 4.
Outside times the whole thing would be 5 times x plus 5. And then the outside times the whole thing would be 6 times 10.
Wait. What?
Oh, outside, I'm sorry.
Outside is 5. Whole thing is x plus 5. Outside is 6. The whole thing is 4 plus 6. What do we do on these?
Oh, you the x squared.
Square the tangent. Outside times the whole thing. And then solve it from there. We should be good on circumference, right?
Should. Yeah.
If it gives you the r, do 2 pi r. If it gives you the diameter, do the diameter. Pi times b. So, this is the part we need to get. If it says find arc length, the degree over 360 times 2 pi r. So this will be 120 over 360 times 2 pi 5. Make sure if it's one like number 3 over here, you do the correct angle. If I'm doing BCD, that's going to use the 210. If I do BD, what angle would I use? If I'm trying to find BD, the length of BD.
You would use
360 minus 210, so that part would be 150, and I'd do the same process as that first one. If it says anything else other than arc length, do the proportion. So arc length, it says find the measure of the arc, which is the degrees. Set it up, cross multiply and divide. If it says find circumference, what are we going to do?
For the radius, you do the area.
No. What is the arc length on this one?
Arc length
2 pi r. What is 2 pi r?
that is circumference.
That is circumference, so I'm going to take it out and put the c in there. Degree over 360. Cross multiply and divide. So if it asks for circumference, I'm taking 2 pi r out and putting that in. If it says find the radius, what am I doing? What am I doing?
my bad.
And what did I tell y'all about this 100 times?
You gotta put it as a fraction.
If you don't put it as a fraction, it's going to mess it up. So make sure that's typed in as a fraction.
I ain't can't do it.
If it says find r, what are we going to do first? Find the circumference first, doing the same process as before. Then plug that number in, divide by 2 pi. If it's the area, we're good on finding the regular area, right? Pi r squared, plug the r number in, make sure it's r. If it's the area of a sector, degree over 360 times pi r squared. How do you find the other degree on this? Subtract from 360? Is that what you were going to say?
Yes, sir.
It's going to give you one angle. You do 360 minus whatever that angle is to find the second one. So on this one, I would say AB is the 106 over 360 times pi 9 squared. ACB would be 254 when I subtract. If it says find anything else other than the area of a sector, go back to the proportion. You would say area of a sector goes there. Area of the whole circle, where does that go in this formula? So I'm going to put A in the pi r squared spot. Degree always goes over 360. Cross multiply and divide. If it says find the radius, I'm going to set it up. Find an A. And then do what? No, once I already found A. I'm looking for R. So I'd have whatever that is equals pi r squared. Divide by pi. And then you'll get whatever this number is equals r squared.